Yes, now you can see. Shall we move for the 30th question? It's given Anya invest $6,000 in the account that pays compound interest on compound interest. Okay, not simple interest, it's the compound. Compound means annually it is increasing. R% per year. And at the end of the 8 years, the account has earned six but 621.70 in the interest. Calculate the value of what is calculate the value of R. Yes. When you are doing how to do this one, you have to remember. Okay. If I taken for the 2 years, look at here. I write in this one. Here, compound interest is what? It's annually, it's calculated each and every year. Okay, if I consider like here for this question, okay, if I taken what is the interest for 1 year? Interest for 1 year, okay. Here the amount 6,000. Interest for 1 year R over 100. Here interest for 1 year. Clear? Interest for 1 year is R over 100. If you consider interest for 2 years, another R over 100. Interest for 3 years, another R over 100. Like that one, it's taken how many years? It's taken how many years? 8 years. So you can write here 6,000. How many R's? There are 8. So R to the power 8 over here. How many hundreds there? How many hundred? There should be 8. Here the calculation. Clear? Here the calculation is equal for what? When you simplify that one, the amount of earn as what? Earn should be 621.70. 621.70. Now you have to calculate what is the R. Clear? Present be my 100. Clear? If you consider what that amount of compound, it is multiply each and every year. If you are taking simple interest, it's not like there. There, if you consider simple interest, what should be there? R into 100 for 1 year. If you consider 8 years, you have to multiply by 8. Here the simple interest. But it's not a simple interest. It's compounding. Compound means you have to multiply each and every year. Clear? Now subject R and found it. So what is the R8 is equal. If I take it, divide this one goes to other side. Here 621.70 multiply 100 to the power 8 over what? 6,000. Can you calculate this one? Use the calculator or anywhere. What is the value for R8? Find it. $621.7 multiply 100 to the power 8. Should we have a scientific notation? Better to use scientific cal. Okay. And divide by what is 600. Okay. They are having online calculators if you want. Simplify using the cal. 621 into 5 using scientific cal online. Here the answer. And this value, what should be there? You have to consider all of them. That root of 8 should be. Okay, when you are getting the answer, here the answer, you have to consider root of 8. What is that? It's near to 75 point something. Correct or not? Check, okay, yes. It's better to use scientific cal. Yes. You can get it, no? get the answer for the R accordingly. Use the cal, you can find it. Okay, don't take much time. What is the next one? A directly proportional for the square of x plus 3 when x equal 2 and y equal 5. What is that? Y is directly proportional for the square of x plus 3 when x equal 2 and y equal 5. Find value y when x equal 1. They ask it the value of y when x equal 1. Yes, continue. And do next one also. Try. Okay. There are given y is directly proportional for the x plus 3. So directly proportional mean so any number of what multiplication of x plus 3 should be equal for the y. Okay, when y equal 5 it should be equal for other side also. When y equal 6 like that on. They can be taking any value. They ask him what is the direct proportional value. So how to solve that one? They given like here. You can write y equal directly proportional. What is any value for that? K x plus 3. Because this is directly proportional. Okay, it's directly proportional. Now substitute the values. What is the y here? What is the y? 5 they are given. Equal for k. X is equal for what? X is equal for 2 plus 3. Clear? X is equal for 2 plus 3. And square of this one. Not only that, square of this one. Clear? Square of this one. Now 5 equal k times 2 plus 3. 2 plus 3 also 5. 5 squared. So 5 equal k times 5 squared is what? 25. If I subject k, if you subject k, what is the answer? Both sides can be divided by 25 no? Clear? 25 cancel. How many 5s there? There are 5. So k equal 1 over 5. Okay, I found a value because this y is directly proportional. So you can write for, if I consider square of this one, so it should be equal for this one. So what is the equation now? Let me know. Y equal, yes, 1 over 5 x plus 3 square. Here the equation. I already find. Now they are asking what happened? Find y when x equal 1. If directly what? Directly proportional this one. Now you have to find when what? X equal 1. Find it. When x equal 1, y equal 1 over 5. X is 1. 1 plus 3 squared. So y equal 1 over 5. 1 plus 3 is what? 4 squared. What is the 4 squared? 4 squared is 16. So 1 into 16 is 16 over here should be 5. Is that clear? They are given the proportional to directly this one. So if you wanted to simplify this one, if I simplify 3, remainder 1, 3.2. If you want, write it as a decimal form. No need to write decimal form. Just write as a fractional form. That is all. Clear? If it is directly proportional, you can write like that. Okay? Inverse proportional. If there are inverse proportional, you can write 1 over k. But it is given as a directly proportional. Okay? Write it. If there are given as directly proportional, you can write like that. Okay? If there are given as directly proportional, you can write like that. Is that clear? They are given it as a what? Directly proportional. You can write it as this. And next thing, a bag contains 5 green buttons, 2 blue button and 6 white button. Maya takes 2 button randomly from the bag without replacement. Without replacement means if I can take one button first time, second time you cannot take the same button. Clear? Here like here, look at here. They are having 5 green, 2 blue and 6 white. Okay. Without replacement means if I take first time take a green button, in first time they are having how many buttons? 5 plus 2, 7. 7 plus 6, how many buttons? There are 13. In the first time they are having 13 buttons. If I take a green button first time, how many remaining buttons there? Now remaining, how many buttons? 4 green buttons. Because already I taken green button. Altogether how many buttons now? 4 plus 2, 6, 6, 12. In the beginning they are having 13 buttons. But second time you have to think with the 12 button. That's called without replacement. If I take a button first time, second time you cannot take the same thing. Clear? Same color or same button. It may be have same color because they are having 2 buttons each of every color, 2 or more. Now they ask a calculate the probability that one button is green and other button not green. First button is green, other button not green. How to do? Can I erase this one? 14. Okay. How to do? What is the probability? How to find probability? You have to take that correct one, divide by the sample space. In the beginning altogether how many buttons? In the beginning altogether in the beginning altogether they are having green 2 5, blue 2 and green 5, blue 2 and 6 white, altogether 13. First time I take 1 and secondly they are having 12. You have to consider with 13 first time and second time you have to take with the what? Second time you have to consider with the 12 button. Now how to do? Now they asking calculate the probability that one button is green and other button not green. Okay, there are 2 options. Look at here. I take it with the green with the tree diagram. Okay, here the first option. It may be a green, it may not be a green. How many green buttons? There are 5. Okay, altogether there are 13. Out of 13, how many green buttons? 5 buttons. Not green, how many buttons? Not green, how many buttons? Not green, how many buttons? Here 5. Other should be what? 13 minus 5? 8. Good. Here the first choice. Now second choice, if I take the green button, second time they are having out of, it may be a green or not green. How many buttons there are altogether now? 12. If I take the green button first time, how many remaining green? Previously there are 5. I take 1 green. How many? There are 4 more. Clear? If I take green first, okay, this branch means, upper branch means, they are taken green. How many non-green? All 8 are what? Non-green. Because I take the green. If I not taken the green first time, what is the probability? If I not taken the green first time taking the blue or white. Second time also can be have green. How many greens there? All what? All 5 are remaining because first time I taken not a green one. Now I not taken the green one first time. There are not taken 8 there. Now I taken what? Not green one. There are 7 remaining. Altogether 12. Clear? Can you clear this tree diagram? How to draw in that one? Is that clear? Do you want one more? Okay, first of all, is that clear? I will give another one for you. Okay, don't worry. Now they're asking calculate from one button is green, that other button is not green. What is the chances? What is the chance? One button is green, other button is not green. Here one chance. First time green, second time not green. Otherwise, first time not green, second time green. Can you say what is the probability of here? You have to, when you are going through these branches, you have to multiply it. What is there? 5 out of 13 should be multiple 8 out of 12. Here 1. Simplify. Is there cancel any values? No. Here 40. 12 out of 13. 12, 144, 156. Yes, it can be simplified. Okay, I just write it. If you want, you can simplify. How to simplify? Here actually 1 by 4. How many 4s? There are 2. There are 3. Now we see. 13 into 4. 13, 26, 52. Oh, my bad. Here should be 3, no? Ayo, yes. It should be 3. How many 4s there? 3. Now, if there are 3, what is the value there? If there are 3 into 13, here 39, here 10. 10 over 39. For this one, multiply 8 over 13 plus value. Second one, 5 over 12. Any cancellation? Yes. Here also you can cancel by 4. Here 3, here 4. Here 2. How many? Yes. Same value. Here 10, here 30. 39 out of 10 plus 39 out of 10. What is the probability? 39 out of, both are okay. Both are okay. So it should be 20 out of 39. So answer should be 20 out of 39. Here the probability. It's better to draw what? A tree diagram. I will give another question for you. Write down that. Yes, I will draw some. First of all, write it. Yes. I give some more questions. Okay. There are given one button green, other one not green. It's better to draw this kind of tree diagram. Okay. Yes. I give one more question for you. Okay, there's one more question for you. I raise this one, okay? Look at it, when you are practicing one more, you can get the idea. When you are drawing tree diagram, you have to thinking, okay? There can be draw a grid like this, otherwise you have to take a tree diagram. So they are having two options. What is that? Replacement and without replacement. Okay, replacement and the without replacement. So these kind of thing we are taking as what? Without replacement thing. Okay, without replacement thing. Okay, so yes. Can you do this one? Third question. Here, good question. Third one. In the back, they are having 4 ripe wood apples and 3 unripe wood apples. Altogether, how many wood apples there? 4 ripe wood apples.
7.
7. Good. Altogether, they are having 7 wood apples. Okay. In this bag, they are having 7. Okay. Now, normally, however, name draw a fruit from the bag. It is ripe fruit. She will be randomly draws out another one. Randomly draws out another one without replace in the first one. Okay, try. I give you 2-3 minutes. Try first. After that one we will discuss. Okay. Now randomly take a if it is ripe fruit, she again randomly draws out another one without replacing it. If the first fruit is unripe, she put it back into the bag, randomly draws another fruit. What is there? There are two incidents. If it is ripe fruit, she again randomly draws out another without replacing first one. But if that one unripe, she put it back for the bag, randomly draws out another fruit. This is something harder question. Now how to draw this one? First time, it may be what? It may be ripe or unripe. Okay, first time, here the first branch. Okay, it can be ripe or unripe. Clear? Altogether, they are having 7, no, 7 would happen. What is the probability of ripe? They are having 4 ripe and 3 unripe. 4 ripe and 3 unripe. Is that clear? No? First time is clear. But second time, they are given a condition. If it is ripe wood, if it is ripe wood, they check in again ripe and unripe without replacement. So second time they are having only 6 fruit. Why? Already taken out 1 if it is ripe. Now how many food items there? There are in the beginning they are having 4 ripe and 3 unripe. First time if I take a ripe one, they are having 3 more and 3 unripe thing. Clear? So here should be 3 and here should be another 3. 3 out of 6 and 3 out of 6. Is that clear?
Yes.
And the other thing, what is other experiment? Other experiment something different, okay? What is other one? If first fruit is unripe, she put it back into the bag randomly. Put it back. That means again they are having 7. Randomly draws out another fruit. Randomly draws out another fruit. What is there? If I unripe it, what happened? Again, she taken with the same thing. What is there? First time they are having 7 again because again put it back to the back. No, they are having 4 ripe and they are having 3 unripe things. Clear? Clear? Because she put it back if it is unripe. Something different thing. Now they ask it the first fruit is being ripe and second fruit being what? Being ripe. And two independent events. First fruit being ripe and the second fruit being ripe. Both are ripe. What should be there? Which branch? First one ripe and the second one ripe. This branch, no? So what is the probability? What is the probability? You have to multiply 4 over 7 into 3 over 6. Clear? Now if you want you can cancel 3. How many? There are 2. Here 2 into 7, 14. Here 1 into 4, 4. And you can simplify again by divide by 2, 7 over 2. What is the probability? It's 7, 2 over 7. Clear? That's calling ripe and ripe. Take a note please. Can you write? Yes. I think you can do this one. Quickly do. I don't give much time. Okay? Yes. Shall we start? They are having 10 bulbs. Same time. 3 known as what? Faulty. A person randomly drawn out a bulb from the box. Check whether it is faulty. Without replacement. First bulb he drawn out and another bulb checks whether it's faulty. Okay? There are 10. There are 10 bulbs. 3 faulty. 7 are not faulty. 7 are good. Okay. Experiment in the tree diagram. Yes. No need to take second one, no need. Third one, find the probabilities. Yes. This one, no need. Yes. Find the probability. Bulb is faulty. Exactly one bulb being faulty. At least one bulb being faulty. Yes, no? Okay, so here I represent with the tree diagram. The best thing, they are having two teams. They are having box in the 10 bulbs. Same in 3 are faulty and 7 are good. So altogether, faulty I take it as a faulty and not faulty. Faulty, not faulty. So how to draw here? Yes. Altogether there are 10 bulbs. No? Out of 10, how many faults? See? There are 3. There are 7. If I take the faulty one first time, this is easy. Second time also can be have a faulty. Oh, not faulty, non-faulty. What is the probability of? Now, already they are having 10 bulbs. I check one faulty one. There are 3 faulty in the beginning. I take in one out. They are having another 2 faulty. But altogether, how many bulbs now? Altogether, how many bulbs? There are 9. If I take faulty one first time, they are having all non-faulty. 7 bulbs are remaining out of 9 because already I take one. Okay, if I take the faulty one first time, second time also can be have a faulty or non-faulty. Non-faulty. So what is the 41? Altogether they are having 10. I take 41 first time. They are having 7 non-41. I take in non-41 first time. They are having 6 more non-41 out of 9. Clear? They are having 6 more non-41 out of 9. All 41 is remaining out of 9. Clear? Is this clear, this one? Drawing this one? If this one clear, you are success. Is that clear? Drawing this kind of tree diagram. Now they ask you first time, both are faulty. Both are faulty. So, first one faulty, second one faulty. I write it in the group. First one faulty and second one also faulty. You have to go through this tree diagram. So, how to multiply? First one faulty, 3 out of 10. Second one also faulty, 2 out of 9. Any cancellation? Yes. 2 and here 5, there are 1. Here 3, there are 1, there are 3. So you can multiply 1 into 1, 1. 3 into 5, 15. So it's both are faulty. They are having less probability. 1 over 15. Clear? Both are faulty. 1 over 15. Second one. Exactly one bulb will faulty. Exactly one faulty. Exactly one faulty means first one faulty, second one should be not faulty. Only one, no? If first one not faulty, second one should be faulty. Both should be. You have to take this one and this one, both should be adding. What is the upper one? 3 out of 10 into 7 out of 9. And also, you have to think what is other one? 7 out of 10 into 3 out of 9. Now add both. When you are adding, you can cancel this one. 3, there are 3. Yes. Now here 30 into 7. Here any cancellation? Yes. There are 1, there are 3. Same. 7 into 1, 7. 30 over 7. So 7 plus 7, 14 over 30. If you want to cancel by 2, 7 over 15. Clear? And what is the other one? At least one bulb will 40. At least one bulb will 40 means it may be both faulty. It may be what? One faulty. Not both are non-faulty. So previous one both faulty. What is the probability of that one? We already find both faulty. It is 1 over 15. And exactly one bulb, it's 7 over 15. All together, you have to add here 8 over 15 because I not calculate only last branch. It is both are non-faulty. They are asking at least one bulb faulty. It may be both are faulty also. At least one bulb faulty means both are faulty also. So I can consider first one and the second one all. You can add all. Clear? So this kind of question may be interesting. Okay? It's better roughly draw a tree diagram like this and do the calculation. When you are going through the branches, you have to multiply, and if you take in one branch and the other, you have to add them. Okay? When you are going through branches, you have to multiply. When you are going to one branch another, you have to add it. That's the way. That calculation. Okay? Write it. Okay, no? Yes. You can do like that kind of question going through the tree diagram. Now next one. They are asking find the magnitude of vector, and the diagram show triangle OAC. A is midpoint of the straight line OB, and OA is X and OC is Y. Find the CB is terms. Okay, vectors. I will explain this one. It's better to explain it day after tomorrow, no? So please write these answers and send me back. Clear? Can you please write these answers, all of them, this note, and send me back, okay? Sure? Again write, okay? I take 3-4 questions for day, but it should be important because I write another question that's going nearby there, okay? And next day I have to do this vector part, okay? And diagram of OAC, it's containing, okay? And when you are simplify this kind of thing, you have to think with the power of 4 or 3 there. Okay, all of them, these values. Okay. So can you do this one now? Now, vector part I will do. Can you just do it this one? This power for 3 or 4 is apply for what? Both numbers because they are having bracket now. Can you write? How to write? Here they are having 81. Yes, please write. Here having 81. This 81 apply here. What is the power? 3 over 4. Also they are having x to the power 12 and the power 3 over 4. You can clearly see this 4 and 12 can be cancelled. Remaining what? How many 4s there? 3. Clear? 4 and 12 can be cancelled. This 3 over 4 is applied for both because it's a bracket, not only one. Clear? So here you can cancel because of that. Now it's cancelled by 4. Can you write 81 is the power of 4? 81. 81 can be write like this, no? 3. 3 into 3, 9. 9 into 3, 27. 27 into 3, 81. So can write 3 to the power 4, no? If you want, I write 81 as what? 3 to the power 4 into what is there? 3 over 4. Here it's cancel. 4 and 12 cancel. Remaining 3 into 3. What should be there? 3 into 3. It's 9. Here also 4 and 4 cancel. Remaining 3 to the power 3. 3 to the power 3. And here x9. If you want, you can write what is the answer for 3 to the power 3. 3 into 3, 9. 9 into 3, 27. The final answer, 27x9. You can simplify like this. What is the 27x9? Is that clear? We can expanding. Okay? Because of this one, you have to think with this power. You have to think with this power. Okay, according to that one, I simplify because they are having over 4. So I try to write 81 with the over 4 and also x with the over 4. Clear? Is it fine? Yes. Okay, write them back, please. Okay, please write them and send me back today all the questions, and I will explain this one tomorrow, day after tomorrow. Okay, other question vectors. It's something I want to take some time. Okay, so I'll wind out for today. So we'll meet up on Wednesday. Okay, so thank you very much. We'll see you on Wednesday. Okay, so good night to you. See you.
Okay, thank you, teacher.
Okay, see you. I will share the recording.